That would be pretty cool.
You
Okay.
know, like big here 6.
Yeah.
All right, guys. A quick little lead into this, which is go way back to the basics of math, algebra. If you say x squared equals 9, how many answers are there to that question? There's 2 answers. So there's a lot of these that are going to have more than one answer because when you ask a question like that, well, sometimes there's more than one answer. All right, so we're going to see on these. I see some of you guys got a little bit of a head start. That's fine. So when you see this equation, 4 multiplied by the sine of x plus 11 equals 13. So the question is there an x value or multiple x values that make this equation true? Now the question says you're looking for an x value on the interval of numbers from 0 to 2 pi. Okay? So you're thinking of if you think of x as being some angle measurement on a unit circle, they're talking about under 1 full counterclockwise rotation, how many values do you hit along the way that satisfy this equation, that make it true? Do you understand the basic idea before we get into the calculation side of things? So the trick, it's not a trick, the idea is to treat this just like it's a variable, like that was a single entity. Ultimately, yeah, we're solving for the x, but until you isolate this term, just treat it like a variable. So the first thing would be subtract 11 from both sides. 4 times the sine of x is equal to 2, and then divide both sides by 4, and you get this. The sine of x equals positive 1.5. And then you say, wait a second. I have studied the unit circle, and I know that there are spots on the unit circle that give you a sine value of 1/2, and those spots have to do with these, well, this, in this case, it's this triangle. Okay? Later on, pretty soon we're going to also want to get this triangle involved. Now, not every single one we do involves a triangle, because sometimes you end up at like pi over 2, 3 pi over 2. Okay, so how do I position, the question becomes, how do I position a point on the unit circle in a way so that its vertical component, its y component is 1/2? Do you understand that idea?
Mm-hmm.
So that would be here, pi over 6, and here, and 5 pi over 6.
Mr. Hall, can I see Hunter?
He is in the library.
Okay, thanks.
Okay, do we understand why those 2 positions are satisfying this?
Mm-hmm.
Yes.
No questions? Okay. Okay, so the answer is my x values are 5 over 6 and 5 pi over 6. And then if anyone's thinking, well, wait a second, couldn't I wrap around the circle and do like 13 pi over 6? You would be correct if there wasn't this restriction on the question. You certainly could say, well, actually, there's an infinite amount of numbers that work for this. For example, pi over 6, 13 pi over 6, 25 pi over 6, 37 pi over 6. I could just go forever, right? Just keep adding 2 pi onto it. But a lot of times they'll just say, just do 1 cycle around the circle and identify all the values. Okay. Should we look at, let's do C before B. C is a lot easier than B. It's only 1 step of algebra. Okay, let's solve this. Okay, so the first step, of course, is just divide both sides by 2, and you get this. Okay, where on the unit circle would the y value of my point be not only negative, but this negative value specifically? So there's 2 things to think about. Is 1, hope it's apparent that you got to be on the bottom of the circle, right? Because that's where the negative sign values occur. And then this is the triangle you're looking at. And so, okay, to be here and here. Now, how do you describe those angles? Well, remember, we're always going counterclockwise. So this would be 5 pi over 4. So everyone comfortable with getting that number?
Mm-hmm.
Or all the way over to 7 pi over 4. So my final answer is those two numbers.
Wait, why write 7 pi over 4 instead of negative pi over 4?
Good question. So, yeah, like negative pi over 4 is a valid solution to this equation, but it's this condition that we're asked that's like above the
Oh,
very top of the page. No negative number is in that interval. If you're wondering, the way you write, if you wanted to make an exhaustive list of every possible solution, like say this requirement wasn't here, you would simply go, you'd say, well, any number that's 5 pi over 4 plus some integer multiple of 2 pi. So n representing some integer. Does that make sense? So you could say, oh, 5 pi over 4 plus 2 pi, or plus 4 pi, or 6 pi, or minus. I could minus pi, minus 2 pi, minus 4 pi. You do the same thing for that one. Make sense?
mm-hmm.
If you want to be really bougie, you'd say something like the set of values of the form 5 pi over 4 plus 2 pi n such that n is an element of the integers. And the curly brackets meaning a set of numbers. That's if you're really trying to flex your notational skills
Fancy.
on all the haters out there. You know that feel when the haters tell you that you couldn't use set builder notation? You just show them all. You just show them all. You get that glow up. Feels good. Okay, it's a good beat. This says, I'm going to write it a little bit differently. Hopefully everyone's okay with how when you write secant squared of x, that's the same as secant of x squared. Just trying to
I think a lot of time can be wasted in that. So I think it would be worth checking out shortening the sec x to just sex.
wow. Think of how savage that would be. Wow.
That's all.
You made him lose the train of thought.
Anyway. How do we approach something like this? Well, the answer would be, who knows? It's a one-word answer. What approach would be used to factor it? Yeah. And if you're not seeing that right away, what you want to do in your mind is go, well, is that really any different than saying, q squared plus 3q plus 2 equals 0? Is it really any different? No. Some quantity squared plus 3 times that quantity plus 2. And of course, you'd factor this as q plus 2 times q plus 1. So we're going to do that exact same thing, just using the secant of x as our quantities. Secant of x plus 2, secant of x plus 1, 0. Okay. So there's two possibilities. Either your secant value is -2, or your secant value is -1. One of those must be true. Something to think about going forward is suppose you do this process and you get something like, just think completely different. Suppose you do a factorization and it goes, oh, cosine of x equals 3. What kind of solutions would that generate? None. It wouldn't.
Oh.
Right? There's no angle, right? There's no, you can't have a cosine of 3, right?
No.
How could you, like, look at your SOHCAHTOA. How could your adjacent side be 3 times bigger than your hypotenuse? It makes no sense. Possible. So the biggest that cosine can be is 1. I'm just throwing that out there, guys. You might encounter a couple like, oh, I factored and this one doesn't seem possible. That can happen. Okay. All right. Anyway. This would be like saying the cosine was negative 1 over 2, or the cosine was negative 1. Circle time. Where, oh, where would I get a cosine of negative 1/2? Up there. That's 2 pi over 3. Or down here. That's 4 pi over 3. Are there any questions on getting those two numbers? Notice that both of those locations, if I drew the triangle, the x component would be negative 1/2. It's this triangle turned on its side, so that can fit there. Same thing with this one. How about this? How do I get a cosine of negative 1? Pi radians. So my final answer is x could be 2 pi over 3 pi or 4 pi over 3. That's my final answer. Again, there's an infinite number of answers, but with this restriction, that's the only 3 locations between 0 and 2 pi that make it work. Okay. So I hope that is an adequate number of what do you call them? Examples. You guys feel okay with the idea? You guys just try to solve a few on your own, see how you do, compare answers with your classmates, and we can go over some more examples if you need. Video